we'll record that. Apologies. So the last webinar, we talked about an introduction, an overview of the platform. We went through overall the process, structure of the project, and I will be sending links to that as well. Today, we want to talk about prioritization and decision making, also with PRIZ Innovation Platform. Now, decision making many times seems very simple thing, but actually, in reality, people stalling a lot on it and spending a lot of time. Now, we like to give some quotes, and we are our own choices, and that's really is we are eventually what we choose to be. Now, decision. Oops. Now, how people mainly make decisions? What's their main drive? Can you guys think about anything? Since we have a little bit smaller forum, it'll be more interactive.
Pros and cons.
Pros and cons. Any other ideas?
Decrease the level of suffering.
Closer to that. Many, well, not many, but majority of people in the world, unfortunately, making decisions based on their emotional intensity, based on what they can lose versus gain. So their main driver going to be, if I make one decision or another, what can I lose? Only then they will think about the gain. So fear of losing is much stronger than desire to acquire something else, even something bigger. And there is numerous examples for that. For example, if we're changing a job, what will I lose potentially if I will change a job versus what kind of position I'm going forward for, and so on. There is numerous examples. So if we want to convince somebody to a specific decision or help somebody with a specific decision, we need to reduce this. We need to explain how losing, whatever considered losing, is not that big of a deal. And that makes people much easier to make a decision. Now, in decision making, there are several. We divided it into 3 zones, and this chart is time to decision making versus expected severity to mistake. So basically, how long will it take to make a decision versus that potential risk of what I'm losing or what I can potentially lose, the risk, right? And we really divided it into 3 zones. The first zone is fairly fast decision making, and it's the low severity for mistake, and it could be choosing between different beers or choosing something small. Usually it's between equal options. Let's just take an example, the same choosing of beer. If we choose one over another, the risk of that is very small. In the worst case scenario, we're not going to drink it. There is no cost to that, or very little cost. This zone where the time to decision could be super high, it could be weeks, for example, when we're buying a house, one house versus another, or even would we buy a different house? And the cost, of course, potentially very high because we're investing a lot of money. And it's not only houses. If you think about how long it takes to choose a car, how long it takes to change a position at work or something like that, the cost might be high. That's why a time to decision could be fairly high. The third zone that we defined is extremely fast decision making. And this is basically a life and death situation when people think within probably milliseconds and decision is made. Good or bad, that's a different story, but the decision will be made very, very fast. Now, we will not concentrate on zone 1 and 2. What we want to do in here is concentrate on zone 1 and 3. What we want to do is concentrate on the second zone, because this is the majority of cases. And another example for that could be, you coming to a manager and asking him to go for vacation or conference or something like that. Many times, more often than not, a manager will say, you know what, talk to me in a week. I need to think about it. Familiar with that? Now, the reality is, during that week, nothing actually happens. It's not that that manager will get additional information. Same as here with the cottage versus penthouse. When we already looked at several houses, most likely there isn't a lot of additional information that will come towards our way to help us make a decision. We're just postponing that decision making further, because maybe something will help us make that decision. And reality is that we just postponing that risk taking. Now, the question is, how do we prioritize? So here's way back to the same beer. And I will ask again, you are in a bar, there's 100 choices of beer. How do you make a choice?
Sometimes we make choices kind of intuitive, kind of what we feel like at the moment.
Okay. Anybody else?
Yeah, very often based on your experience, based on your preference, based on your background.
So preference, experience, background, which is basically experience in a way. So something that you already
Sometimes
did in the past. Yeah, go ahead, sorry.
Sometimes cost as well.
True. Okay. Cool. So now let's say you chose a bunch of, let's go back to this case. You chose you tried several beers, but now what, right? Which one is the best? Let's take it one step further. Which one is the best? How do you compare? You tried 5 of them over, hopefully not within the same day.
Yeah, you have some, again, this is your experience from the past. You know what you prefer and you go for that.
Okay. So the thing is, in like any normal average human being, for average human being, it's really hard to compare more than 2 things at once. And when we have this situation, comparing between 2 things, 2 cars, 2 houses, 2 houses and cars is a little bit harder because there is more parameters. But when you have a simple choice, right or left, take a new job or not take a new job and stuff like that. When you compare them between 2 choices, it's actually much easier to make that choice versus make a choice out of 10. Even out of 3 is hard. Now, and for that, there is a tool called round robin ranking. It's also called pairwise comparison. It's been existed for a while, and some people know that. But the idea here, if we have many options, we start comparing and presenting that to the user in pairs. Now, regardless of how many these options we have, we're still concentrating on these pairs on these pairs over and over and over again. Now, in addition to the fact that we comparing just pairs without thinking about everything else around us, it makes us also rethink the same options over and over again. Now, and that's about it. We'll want to dive into a very quick case study. And in this case, it's from history of Anatoly's work in Intel, so excursion with a dry age. The platform offers several tools as we looked at last time, and right now we have 10 of them. And today we'll concentrate on round-robin ranking. Now, this is a very important tool. As simple as it looks, it actually integrated in almost every place in the platform. Because the whole idea of the platform is to generate ideas, generate options, generate many things. This tool helps us to eventually make a decision. Now, we will also touch a little bit on an effective brainstorming. Anatoly, anything to add in here?
No, it's okay.
Mm-hmm.
Yeah, just continue.
Okay, so what's the typical process of that type of work? Now, when we run into an excursion, first of all, what is the excursion? Excursion, something happened, something unexpected. In this case, it could be elevated number of defects, yield drop, shift of any parameters measurement, anything that unexpected in production line, for example, it considered an excursion. Now, the typical situation, people start brainstorming. Now, they collect people in one room and start throwing ideas and collect these ideas, which is great. But now, what do you do with them? These ideas need some tool. In this case, we're talking about round-robin ranking to process these ideas and to rank them. And as I mentioned before, this process will make you judge each idea over and over again. Now, once we rank them, and we'll show you an example, once we rank them, the correct answer, not necessarily the first one, but it's always going to be at the beginning of the list. So for example, if we have 20, if there is any systematic approach to that, of course, as we all know, the correct option going to be the last, or at least towards the last. In this situation, and this is from experience, it shows that most likely we will see the right answer in the first several options. At the end of the day, we're saving time in this process. Any questions here? Okay, so let's dive into the actual case study. Antonio, maybe you want to take this over?
As you like. Let's continue. I will.
Okay.
I will add something if necessary. Okay.
So, a dry age, it's a piece of equipment that consists of several different pieces. It has a chamber. It has a chuck that holds the wafer. It has the wafer itself that actually the work is produced on. It has several parts. Now, the problem begins this problem that we describe in here is that we have an insufficient edge on the edges of the wafer. It's an excursion, something unexpected. What do we do with that? And potential reasons for the failure, not potential, it's clear that the reasons for the failure is unequal edge rate in different areas of the wafer. Now, obviously, something happened to the equipment that we should fix, and we should fix it fast because these equipment, part of the production line, very expensive if they're not working. needs to be fixed fast. Now, as we mentioned, part of the brainstorming, we came up with a bunch of ideas. And these bunch of ideas are listed here, possible models for the failure. And these models for the failure is basically what we need to check to identify is that idea for possible failure is the actual problem or not. And in this case, it could be wafer shifted from the center, initial. Yeah,
Alex,
go ahead.
just a moment, please. Any brainstorming should be guided. In this case, we guided with a resource analysis. And resource analysis is give us ideas that everything which is within the system could be a resource for the problem. And we go through component one by one, and we think about function of each component. And by thinking about function and component, we create models of failure. And from this, we will get the list of actions that should be done. Okay, Alex.
Okay, anything else to add specific in here?
No, let's continue. Bottom electrode. We have bottom electrode, and wafer is placed on the bottom electrode. There are two functions here: keep wafer and cool wafer. And of course, possible models are that wafer is shifted from the center, and maybe electrode chuck itself or performs unequal cooling. Wafer is another component of the system, which also could be a resource of the failure. You know, we make H from the wafer, it creates gases during the H process. And two possible models could be here. Actually, could be more. We wrote the two. Initial deposition is not proper. Maybe previous operation is not proper. And maybe wafer is bowed. The bowing of the wafer is different from standard situation. Top electrode, you can show Alex with a top electrode is also component which is very important. It supplies energy and supplies gases. There is a holes within. It's like a shower head, and gases go through these holes, and first of all, could be wrong position of the electrode. It could be not parallel to bottom electrode, and holes diameter changed due to wearing during the work. Pump is our exhaust is very important. It's it should keep low pressure to ensure to keep a certain free pass of ions and molecules, and should keep certain pressure within the chamber. Could be insufficient pumping flow or insufficient pressure. Typically, people say, in case of pumping, typically say about pressure. Flow is not easy to measure in vacuum systems, but it's important. Maybe we can measure the time of getting pressure to the certain level. So these two models, and chamber walls. Chamber walls, they only function is to stop air, not to get air to penetrate inside of the chamber. But it's high frequency, very high frequency. Therefore, walls also participate in the impedance of the system. And during the process, we have build up on the old chamber and of course on the walls of the chamber. You know, it's like to add capacitor. And therefore, build up on the walls of the chamber can change impedance of the old system. Now we collected here models, and we can validate these models, and we can go to EBS to the tool. Alex, please.
Yeah. Okay, so I will jump into the tool itself. Then we'll log in. This is screen okay? Now, what we did here, since first of all, we created two effective brainstorming, and again, something. I'll go back in a second. As we mentioned, the actual tool that we're talking about that helps us rankings, helps us making decisions is round robin. But as we mentioned, we still need to brainstorm. That brainstorm where we're collecting these models for failure still need to happen. So this is where the effective brainstorming come in useful. And realistically, effective brainstorming is very similar to traditional brainstorming, where we're collecting ideas, but we have an additional step in here, how we're ranking these ideas. Now, to save some time, we already put all of these models in here. As you can see, we have quite a few of them. It's basically the entire list that we just looked at. Now, to start, of course, we can edit this list.
I'm sorry, Alex. You can read and explain. It's important for next step.
Oh, okay.
Okay. Yeah.
So these, as mentioned, these are models, and as Anatoly mentioned before, the models need to be verified. And verified, it means we need to check this, verify that. It's a list of actions that we need to do. Now, these are the list of actions. Check the temperature of the wafer, validate one model. Check the pump flow, validate another model, and so on and so forth. Verify a wafer bowing, whether it's a good or a bad bowing. Same with the pressure for the pump, and so on and so forth. So all of these are actions. What do we do next? What do we do first to verify one, to verify and find the correct failure model? Any questions here? Now, these actions, this list can be edited. It could be, we can do whatever we need to do with it. We can add into that and so on. Questions? Now, let's continue. So in order to start the ranking process, we completing this tool, and we talked about the completion of tool, what it means in a previous lecture, but basically that's locking the information for reporting purposes. And here we have a ranking of ideas, or ranking of options. And the way it's done is actually very, very simple. As we mentioned, we have we always presented with two options. Now, these are just one-liners. It could include pictures. It could include anything that needs to be included in here. They're all going to be shown. So this is where we, looking at these different options, or in this case, tasks or ideas, and comparing which one we should attend first, which one we should validate first. So in this particular case, we check the pump pressure versus, check if the previous operation was correct, with no violations. we're probably now the comparison is most people asking, how do we make comparison? What helps us to make this comparison? This is very subjective. For somebody, it's important to keep the price down. For somebody else, it's important to resolve the problem faster. For somebody, third is just whatever easier to do and whatever faster to do. It's very subjective, and that decision, it could be based on various different parameters. But same as the problem definition is, it might be very different per person, per use case. Again, very subjective. Same here. It's very subjective, and for us, we might say, okay, it's probably much easier and valuable as well to check the previous operation if it was correct. And we save it and we go next. And again, next pair, verify the wafer bowing versus check the holes in the top electrode, the one that we looked at. This might potentially be easier. Next pair, verify the bowing versus check the pump flow.
Alex, sorry for interruption. How did you get the number 36? Where from these 36 pairs?
If you think about it, we have, I'm not sure how many there are, probably 9 different options, right? So it's a 9 times 9 divided by 2 minus that diagonal.
So 9 is the number of concepts that you want to check, number of hypotheses.
Yes. So if we
Gotcha.
going back to this table.
Gotcha.
Right.
Okay, thank you.
So these are the options. And so on. Verify wafer bowing or check the pump flow. Let's do the wafer bowing again. And so on. We can continue this process all the way to the end. Now, I won't do that because it will take some time. And for that, what we did, we created already ranked example. It's exactly the same example. We just did the ranking previously. And this is what we've got. At the end of this process, what you will get is the same list ranked in order of these rankings. So these numbers is exactly what we get in here calculated. And of course, the highest score is the one that we should start with. And in our subjective ranking, we got that we need to check and remove the buildup from the walls first, and so on. Anatoly, anything to add here?
Yes, if you look in the Google different approaches for ranking and making decision for prioritization, you will see a lot. It's typically a table with a lot of columns, and different parameters should be scored with a score from I saw typical numbers from -5 to +5. It's good. There are only, from my point of view, there are 2 disadvantages here. The first, using these typical tables, you can think, system makes you think about each option once. In our case, you think again and again and again about each option, about each idea in comparison with another idea. The second is a score. For instance, from -5 to +5. This score is make us flexible and actually prevents us from real decision. Because, you know, decision is always yes or no, take it or leave it, 1 or 0. And I think this way is, it looks easy It's easy. It's not such easy, but it's very effective.
Now, there's a lot of applications for this process as well. One of the examples when we were on a demo on a mini workshop, if you will, we were discussing problem statement and how to build problem statement. And the funny part in the process of problem statement which we have, we ask him to describe different disadvantages of the current situation, of the failure, or of the observed failure. Now, the group of people that we were working with, they had, I believe, 4 or 5 different options, probably 4. And they didn't even know which one of these disadvantages they want to address in the first place. And we went into RRR as well, into round robin ranking, to rank these failures, which ones is more important, because it took them, they couldn't decide. And the interesting part, it's just going back to, it looks simple, but it actually not always so simple. These 4 options, these 4 different failures that they were so eager to solve, it took them 1.5 hours to discuss back and forth and decide which one is more important. And that's just one example. Same applies with generated ideas, and we'll talk about these in other webinars as well. The project is generating ideas for the solution of the problem that we working on. It could be multiple ideas. What do we do with them? We need to decide which one we want to attend, which one we want to implement. Same concept as well. Now, particularly in brainstorming, we can, even though we ranked already the ideas of these options, nobody stops us from doing it again, because we looked at this, maybe something is not right. We can re-rank it again, and it will force us thinking about these options all over again. Nothing bad in it, even better sometimes. So we can go ahead and dive into ideas, ranking again, and go through this process all over again. If we don't like it, delete it and go right back. Any questions? Anything to add?
Alex, and what happened if no one of these hypotheses are not reflect the real situation? What shall we do?
What do you usually do?
Generate another one, but it's still the same question I can ask again. I'm trying to resolve the problem and nothing helps. Brainstorming's rank and rating of the ideas, what to do first, what can be neglected, where to put my resources.
I think in this particular situation, the problem is a little bit deeper than brainstorming and ranking, because even if you're ranking out of options that's not even applicable to your case, then it's not going to help, right? Now, it probably requires to go a little bit further back to the drawing board and look for help with the different tools, like potentially functional modeling. And functional modeling, or even understand where the problem is coming from. Why is it even appearing? We have the tools for that, and that's the cause and effect chain or 5 whys. There is additional tooling that we can apply for finding these different options, or actually building the failure model, understand the failure model in the first place before we go into the ranking.
I see.
Right.
Oh, that's definitely makes sense. Okay, thank you.
Right. So ranking is just a tool of making a decision out of many options, right? But yes, the options need to be generated to the point. They need to be generated correctly. And again, we will present these tools. And there are several case studies that describe in our blogs. I will happily send some of these examples in there for functional modeling and cause and effect chain as well. Any other questions? No, just a note, the entire project, if you remember from the last, whoever remembers from the last webinar, all the information about the project is collected inside the report. Same here, all of these brainstorming results and the ranking results, they're going to be shown in the report as well. Questions? Anything else? This one was short, fairly. Sometimes it's much shorter to show the concept than actually working on it. It is very important tool, and again, this tool is integrated almost in any place in the platform to help, because we're making decisions all the time, and it's something that helps us to make the decision.
Is there any way to minimize the level of subjectivity when you work with this tool? I mean, to make it more objective, I would say. Because definitely the models that you compare and you choose for comparison, this is actually based on your personal experience, tradition, etc.
Correct.
So
culture in the company.
of course, yes.
It could be, so that's exactly the reason it's almost impossible, because let's take Intel, for example, right? Intel don't care much about spending additional money to solve the problem. All they care about is time. Some other company, a smaller company, might say, well, time is very important, but we're also tight on budget, right? Decision is completely different. Somebody else says, we very climate conscious. We want to do everything, but not to affect the climate. Okay, so to make it more objective with the system, like in some automated way, I'm sure we'll start reading minds at some point. That will help, but in general, I don't think it's even correct. What we do, we help people focus on things. Right.
I want to add something. I think this is the best way to run out of subjective impression, because you are comparing each solution, each idea to all other ideas. If you work with traditional ranking and you just working with the table and think about each one separately, you are thinking, you are judging much more subjective. I think this is the best way to run out of subjective bias. I don't know.
I would like to jump in on this question, if you don't mind, because I'm really fascinated by this question of what is objective in the first place, right? And I think with this particular method, there's two things that come into play. One is exactly what you just said, Anatoly. You know, through the process itself, through that left, right, left, right, left, right, where you do it over and over again, you take away the subjectivity from one individual, right? If I'm having some kind of bias, I'm like, I really like this thing, but then I'm actually kind of making the ranking, and then sometimes I might see something I don't notice yet. But then the other aspect to objectivity is also we have an expectation for objectivity that it's like, you know, objectively measurable in the universe. But the thing is, sometimes, I mean, in this industrial process that you just showed, like if it's right, if it's some machinery, you know, that it is technically speaking objective because you have the machine and everything. But some other problems, they tend to be a little more subjective in the first place. I mean, like for the universe itself, it's not a problem that the machine is broken, right? So that's objectively speaking, is that really a problem? Who cares about that, right? So that's as the baseline of objectivity. So then my opinion here is that, you know, if you really want to make it as objective as possible, you have to take an average across multiple people. So you'd have to run this left-right comparison with, you know, with all 5 team members, and then see the ranking there, and then see what they come up with, and then you can get like an, you know, some type of weighted average that gives you the actual objective answer, which is more so based on, you know, not objective to the universe, but objective to all the participants.
Right. This is actually what happened in my practice, in my previous job in Intel, when guys were sitting in the room and together they did ranking together. And typically, if they have, you know, 20 models, 20 directions, what should be tested in this huge equipment, typically the right one is in the first 3 or 4 lines. This is what happened. You are right. You're right. Of course, if you are not alone, if a couple of guys are working on it, it's much more effective. Yeah.
Forgive me about my English. Maybe the other way to add some objectivity is to divide the decision into parts. I take example just to compare what decision is simpler, and run comparison about simplest this decision. What decision is I don't know, most promising, and compare here.
Yeah, so basically choose one parameter based on which you're going to compare.
One,
right, so
another one.
And that could be just simply parachuted from leadership, from management. They can say, solve it yesterday, as soon as possible, right? Regardless of the money, regardless of what you do. We don't care. We need to solve it now. Or some others might say, you know, here's the budget to solve that. And you constrain with the budget. And there's like, we usually driven by constraint. If we had unlimited resources, unlimited time, a lot of problems would go away by definition. You know, just throw money at it. But that's not the case.
By the way, to make decision is a very, I would say, excited topic. And we have another method how to compare 2 things, how to decide which car is right, and we will show it.
Since we're here, I want to show another real example that we did from several months ago. On a real use case. We're trying to speed up the continuous integration, continuous improvement, continuous deployment flow that's from software engineering. And in this particular case, we had a bunch of ideas generated. And as you can see, it was the same process all over again. We needed to decide which one we even pursuing. All of these ideas were valid, and all of them were great, but now we can't we can't implement all of them. Same concept. It's a decision making which ideas we're actually going to pursue. So we went through this ranking, and this list is quite a bit long. It does take time, of course, but it takes time. This time spent is valuable time spent. In this particular case, the decision was made, back to subjectivity, the decision was made based on how long it takes to implement these different ideas, right? Nothing else. And this is the result that we've got from all of these ideas, where that's the score that these ideas got. And then we decided, okay, these are the list of winning ideas that we're going forward with, because some of them can be combined and eventually generated this final solution. Great. If there is no other questions, we want to thank you. And we'll be sending all the recording as well. And I'll stop recording now.